So for number 4, if s is equals to 3t squared minus 16t raised to the power of negative 2, when will the acceleration be 0? So take note that acceleration is just the second derivative of d squared with second derivative of s with respect to t. So, and we need to equate it to 0. So we need to find first the second derivative. So ds over dt is equals to 6t minus, so it is plus, so plus 32t minus 3. So d squared is all over dt squared, so we have 6 minus, so 32 times 3 is just equals to 96 t raised to the power of negative 4. So we need to equate it to 0. So 0 is equals to 6, so negative 6. So negative 96 all over t raised to the power of 4. So we have 96 all over t raised to the power of 4 is just equals to 6. So by simplifying, we have 6t raised to the power of 4 is just equals to 96. So we have t raised to the power of 4, so 96 divided by 6 is equals to 16. So 16. So t is equals to the fourth root of 16. So t is equals to 2. So at t is equals to 2. So this will be now our final answer. So because we are tasked to find the value of t when the acceleration is 0. So let's check if our answer is correct. T is equals to 2. So our answer, the answer is t is equals to 2, and our answer here is correct. So let's proceed to another number. For number 13, a body is thrown vertically upward from a point on the ground. So we'll draw a body is thrown vertically upward. So let's say this is the object thrown and this is the ground. So let's say this is the ground. And this one, uh, a body is thrown vertically upward from a point on the ground if it attains a maximum height of 400 meters. So let's say this height here is 400 meters. So this is 400 meters. This is 400 meters. And then find its initial velocity. So this is the maximum height. So this is the maximum height. So if it is the maximum height, so it is for sure the body will go down right away after it attains its maximum height, right? So it will go down again. So what we are trying to find is the initial velocity. So how to solve this one is, the problem states that the acceleration is not changing, so the velocity is not increasing, so it is just in normal. The description of the motion is having a constant acceleration. So if we have a constant acceleration, we'll use this formula. V final squared is just equals to V initial squared minus 2JH. So what is our final velocity here? So if the object attains a maximum height of 400 meters, and it will surely falls down right back to the earth, so its final velocity will be 0, right? Because it will fall down back to the earth. So for our v final is just equal to 0. And our V initial, it is what we are trying to find. And our G here is, our unit here is meters. So it is 9.81 meters per second squared. So is it positive or negative? So for this one, the 9.81 is positive because in motion, or in the when we throw up when we throw upward the object, the 9.81 will have a negative, right? And if the object is going down back to the earth, it is positive, right? So for this one, and our height here is 400 meters. So we'll now substitute. So we have V final is 0 is equals to V initial squared minus 2 times 9.81. So 9.81 meters per second squared times 400 meters. So we have V initial squared is just equals to, so what is the 9.81 times 2 times 400? So the answer is 7848. So we'll just use 9.8, right? We'll just use 9.8 instead of 9.81 meters per second squared to have a much so that we can avoid the point. So we have 9.8 times 2 times 400 is just equals to 7840. 7840. So we have meters squared per second squared. So V initial is just equals to the square root of 7840 meters squared per second squared. So V initial is just equals to, so square root of 7840 is just equals to 28 square root of 10. So meters per second. So this is now our final answer. So let's check if our answer is correct. V initial equals 28 square root of 10 meters per second. So our answer here is correct. So let's proceed to another number.